Welcome to EDU World Space.
Okay, so this is problem 34.44. And we're told that the eye is modeled by a double convex lens with an index of refraction of 1.44. And we're told that the radii of curvature have equal magnitude. So R1, R2 have the same magnitude, which I will call R. And you'll have to recall that for the double convex lens, the radius of curvature here, for this part of the lens that's convex is greater than 0, and this part of the lens that's concave, this radius R2, is less than 0 by the convention that's set up in the chapter. We're also given the focal length, and since it's a double convex mirror, the focal length is positive, and it has a magnitude of 8 millimeters. In part A, we're asked to find the magnitude of the radius of curvature. So this figure really kind of pertains to part B, just to give you an idea of what's going on. And so let's go ahead and solve for the radius of curvature. We're going to use equation 34.19. Which tells us that 1 over the focal length is equal to the index of refraction minus 1 times the reciprocal of radius 1 minus the reciprocal of radius 2. I said reciprocal, apologies. 1 over R1, 1 over R2. And since R1, so R1, or rather R2 is negative, right? And they have the same magnitude, then R2 is equal to minus R1. But the magnitude of R1, R2 is R, so I can just write R1 is equal to R. And by this equation, R2 is equal to minus R. Now, if I substitute for R1 and R2 into this equation, then I have n minus 1, and then I'll have here 1 over R1 minus 1 over R minus a negative 1 over R. So then I add them up. So then that's 2 over R, and that's equal to 1 over F. And then I can rearrange so that I isolate R by itself. And then I find that R is equal to n minus 1 and 2 times F. I know N and I know F, so I can immediately find R. N is 1.44. So 1.44 minus 1 times 2 times 8 millimeters. And this gives me 7.04 millimeters. Now in part B, we're given some information. So we're told that the object is placed some 30 centimeters away from the eye. And also that the height of the object is 16 centimeters. And we're asked to determine the height of the image, whether or not the image is erect, which is what I mean by this up arrow, or inverted, which is what I mean by this down arrow, if it's real, which are represented by R, or if it's virtual by V. And just by analyzing the figure here for a image formed by refraction of a double convex lens, you can tell right away, I use the principal ray diagram, that the image will be inverted, but the math will show us exactly that. So let's go to the next page and solve for it. So we're asked to find the image height y prime, and whether or not it's erect or inverted or real or virtual. So how do we find y prime? Well, we know that m, the magnification, is y primed over y. And we know y, but we don't know m. So we need yet another equation to find m. So another thing we know is m, the magnification, is minus s primed over s, which is the object distance over the image distance. We know the image distance that's given to us, but we don't know the object distance. However, we have one equation that will help us with that, and that's equation 34.16. So if we use the things that we're given, so we know s, we know f, we need s prime. So this tells us that 1 over s plus 1 over s prime is equal to 1 over f. So this is straightforward to solve this one for s, which is exactly what we need in order to find m, and then we'll use that to find y prime. So s primed is equal to sf over s minus f. And that is 30 centimeters. And f was given in millimeters. F was 8 millimeters, which would be 0.8 centimeters divided by 30 centimeters plus 0.8 centimeters. So then I can find s prime readily, and it is 0.82 centimeters. As always, I urge you to check that my arithmetic is correct. So you can just plug this into your calculator yourself and verify. Okay, so now that we have s primed and we know s, which is given to us 30 centimeters, we can use these two pieces of information to find the magnification m, and then eventually find the image height y prime. Notice that s is positive, right? So if s is positive and s prime is positive, s prime divided by s is positive, right? Because these are two positive numbers. There's no way they're going to be negative if you divide them. But m is equal to minus s primed over s. So since this quantity is positive, and then there's a minus sign in front here, then m itself is negative. So right away, you can, while we know that when m is negative, this implies that we have an inverted image, which is consistent with the figure we drew. So let's find m. M is equal to minus 0.82 centimeters divided by 30 centimeters. And that gives me 0.025 0.027, negative 0.027. And now we can use this equation to find y prime. So y prime is equal to my. I can throw in some absolute values because we know it's inverted already. So this will just give me the magnitude. So y prime is equal to 0.027 times 30 centimeters, which is 0.44 centimeters. Okay, so that's the height of the image that's formed. And this image is a virtual image this image is a real image. Because S primed is positive. If S prime was negative, then it'd be a virtual image.